Good morning. We're going to work on note card 41, which has to do with Riemann sums equal width. Now, one thing, and even on the test that you recently completed today, there was the word estimate involved. Remember the word estimate involved? Mm-hmm. How was the word estimate used in the test? Well, you may not remember, but you were asked to find an estimate of f prime of some number, of f prime of, I forget what it is, f prime of 3, we'll say. And what happened is, for that you had data in a table that you used. And so you didn't find exactly what f prime was, but you used an estimate by using data on either side of 3, right? So it was something like some number minus another number divided by 4 over 4 minus 2 or something like that, right? Well, what we're doing here with this is Riemann sums are an estimating method for finding the integral of something. So it's not an exact thing, but it's an estimation method. And the Riemann sum is probably the most common estimation method of integrals. And here we say if f is continuous and non-negative on this interval from a to b, then the Riemann sum estimates all these different things. Now here's another thing that it gets into, is that the curve itself is usually going to be the curve of a rate of something. Like if we have this thing right here, a curve of the function v of t, which would be the velocity of t, when you find the integral of this from a certain value, let's see, between a and b, a equals 0, b equals 80, what you have, if this is velocity in feet per second, what is going to be this area under this velocity curve? Okay, you had the velocity change from t equals 0 to t equals 80 seconds, we'll say, and this is velocity, and so this is a curve of velocity with respect to time. What is the area under the curve? Well, the area under curve is going to be the distance. So when you find this area, you have the rate eliminated, and so to eliminate the rate, you need to integrate. Okay, and I made a little song about that. We can do that song a little later. It's a very, very little song. But anyway, what happens is that you don't know exactly what it is, and maybe you don't have an equation for it. If you have an equation, well, then you can use the things that we've talked about and get a exact value, like the one you have in a t-shirt, right? That's an exact value. The integral of that is, of course, 2. But this one here is you'll use this where you don't have an exact thing, where you might just have the graph of a curve. So what you do is you use the Riemann sum to estimate, and then what you're doing is you're going to get rectangles, and the area of these rectangles that are used to subdivide this total area. So in the example I gave here, if I don't know the equation, I can go ahead and take, I'll use this color here. I can go ahead and make a rectangle here, and by the rectangle's length and width, I can, let's see, how am I going to use this here? I'm going to use a right Riemann sum. So it'll be this rectangle here, this rectangle here, and this rectangle here. So what I did is 1, 2, 3, 4, 5, 6, 7. So what I did is I subdivided this into 7 areas with these rectangles, and by figuring out what the width is, in this case we have equal width, and I know I drew 7 rectangles here, but let's just say for argument's sake I drew 8. Well, if I drew 8 rectangles, I would have 8 rectangles whose common width is 10. And so I would have 10 times something plus 10 times something, and you add up all these areas, and you're going to get, now in this case I drew something, I used the right hand of the rectangle, so I went right up to this curve, like I went right up here to this, and it's a right hand Riemann sum. So that's just a little mini example. And so now we go to the next page. Which is right here. And we're going to use a Riemann sum for this one here. It says set up an estimate of the area between the curve g of x and the x-axis using right Riemann sums with 4 subintervals of equal width. And so here we have, it says between -2 and 2. So if we have -2 to 2, and we need 4 subintervals of equal width, what is going to be the value of those subintervals? Okay, we have what that's going to be. It's going to be b minus a. So what's 2 minus -2? 4. And we want 4 subintervals. So I'm going to write that out here. So for the value, so we're going to have 2 minus -2, and we want 4 subintervals. So we divide that by 4, so we get 1. So we're talking about subintervals of 1. So each of these, using equal width, is 1, and it says use a right Riemann sum. So what we do is we're going to start here, and we're going to go all the way to here. And so we go up, it's a right Riemann sum, and so we're talking about our first rectangle is going to have this base of 1, and it's going to go all the way up to the curve, and once we get to the curve, we extend horizontally and then down to complete our rectangle. So this is a rectangle, one of the 4 rectangles we're going to use. And then for our second rectangle, we come up here, we say, okay, we come right up here, and we go over, and so now we have our second rectangle, and then we come over here, we go up to the curve, and then we go to the left, and we have our third rectangle, and finally at x equals 2, we come right up to here, and then go over like this. And so these are the areas we have. This area here, this area here, this area here, and finally this little area here. And then we add up all these areas and we get our answer. Well, okay, what we do here is, let me show you the articulation of it. The estimate of -2 to 2 g of x dx, and so you're making an estimate. I want you, when you write your Riemann sums, to initiate the explanation of the Riemann sums, to say the estimate of, or approximation of, or some sufficient articulation that it is an estimate of the area under the curve. Well, in this case, we know we have 4 subintervals, so another thing I want you to do when you're given instructions like that is write 4 blanks separated by plus signs. And so now you have a template. And so you could write this out before you even calculate anything. And then, so the last thing we need to do is just find out what these are. And we can see that, and it's really subject to sort of estimation of what they are. So I'm just looking up here. This first width of the rectangle is 1, and the height is going to be 1, 2, about 2.5. So I'm just going to say like 2.5 for that first rectangle. For the second one, it looks like we're going all the way up to 4. So that's going to be 4. And then the next one here looks like it's about, what, 1.5? We'll say 1.5. And then the last one here is going to be maybe, I don't know, 0.4, 0.5. We'll say 0.5, right? Now, here's another thing now in this, on the other example on the prior page, I showed an example of the velocity, something like the integral of velocity is going to be what? The integral of velocity, which is a rate, is going to be distance. Okay? So if you have a function of velocity in, say, feet per second, the integral of that is going to be feet. But what you have here is, once you've written it like this in this form, as far as standards and calculus, you don't actually have to add all these up, okay? Because you have given your answer here. So you've given the instructions. When you've given this, you don't have to actually add these up. Now, it's very easy to add this particular one up, isn't it? Because those numbers are things.
But it could be.
Yeah, so 6.5, so it's going to be 8.5, right? But you don't even have to go that far. Some of these gets complicated because in this expression here, you've answered the question. And you're not given any units, so I cannot, in this case, put down feet or amount of gallons or whatever it is that it would represent. But that's essentially what it is. So it's really, to me, this is the kind of thing, like when I took the qualifying test to become a certified teacher in the state of Texas, they tested a wide array of things, and they had 5 questions that had to do with calculus on that test. And I will tell you, when I saw equations, the functions, I forgot how to integrate and take the derivative by that time, having been like 30 years since I'd done it. But I forgot the technique of it. But you know what I remembered? I remembered the concepts. I knew that the integral is going to be area under a curve, so I was able to quickly draw out some little rectangles and add them up and get this question right. So it so happens on that pick your test for qualification to become a teacher, I got 4 out of 5 of the calculus questions right, even though I'd forgotten the details of a lot of what I'd learned a long time earlier. So if you just hang on to this conceptual thing, it can help keep you on track even when you forget some of the fineries of the details. So that's where we are, and we will continue tomorrow.